Thanks for having me, everybody. So this talk's gonna be about AI agents, which is sort of a new space, and so it's something that I'm excited about, and hopefully I'll get you excited about it as well. So a bit about me. So my background, I was actually initially a software engineer, and then moved into cyber. I've been in cyber for about 10 years, maybe actually before. So can everybody hear me? Okay. Louder. Oh, okay. All right. Sounds louder. All right. And then I was in cyber for about 10 years. I started my career in threat intel, building malware analysis pipelines and tracking threat actors. And then I moved to CrowdStrike Services. I was on their cyber intrusion team, so I've seen a lot of cyber breaches, nation state and e-crime, Russia, China, North Korea, Vietnam, pick whoever targets Western entities. And then also split time between the incident response team and the red team. So hacked into a good chunk of the Fortune 1000 as well. I left in 2023 to start a business. We're backed by Google, and we're actually building in the space. I promise this is not a vendor talk. I hate those, and so hopefully we'll be educating folks about language models today. Great, and so that's sort of me. I just think background is sort of important to understand where I'm coming from. So why you should care about this space? I think large language models will revolutionize most industries. It's a derivative of neural nets, and neural nets are what power self-driving cars. I don't think you guys have Waymos out here yet, but it's pretty fun seeing them drive around California. There's just no one in the car, and it drives pretty well. And so essentially, I think you can sort of apply that same idea where you're going to have sort of a machine taking a lot of actions on behalf of something that a human used to do. And I think that'll apply to different verticals. But with that said, I think cybersecurity, due to its low risk threshold, right? If we make a mistake, if we typo a command, if we accidentally delete system 32, catastrophic problems can happen. And so I think cybersecurity will be one of the last industries to fully adopt them, which means that your jobs are all safe. Hooray. But I think what that also means is that there will be human in the loop workflows, meaning that you're pairing with a AI agent to do certain things or to automate or augment what you do today. And so we'll walk through a lot of that today. But point being is that I really think it's a technology that you all should try to adopt. Sort of like email, it's going to be the new standard. Like everybody's going to be using it. And so I think it's important to understand how and why to use it. So with that said, goals for this talk. So basically build the building blocks to understand AI agent terminology and then agentic workflow patterns. And then similarly, sort of make sure that you understand the basic building blocks of AI agents, and so that if you wanted to start writing your own, you could do that. And then last thing is that there are some inherent risks, as I just talked about, and so hopefully we'll talk about some strategies to mitigate those risks as well. Great. I know there's probably a different level of understanding with language models, so I want to do a few quick slides on basics, and then we'll kind of go into, I think, some of the more fun technical things. So what is a large language model oversimplified? If there's actually a real AI person in here, they'll probably not agree with this, but that's okay. So really what it is it's an advanced autocomplete system. I think the simplest version of this is if you guys use like Gmail today for your email, if you start typing a word, it'll know what word you're typing. And essentially it's just that, times 10, where it can start to predict paragraphs and it's predicting the next token in a sequence where a token is just a word, a character, or a number, and it's based on its training set. So large language models have huge training sets, and it's pretty much everything. It could be books, articles, New York Times, YouTube data, and they're sort of cramming it into a training set and then having a large language model learn from that training set. And I specifically put New York Times there because there's an ongoing lawsuit between New York Times and OpenAI, where New York Times sued them for using their data without their permission. I think that is still ongoing. So, but in terms of just like, they pretty much used anything that was public, and they're like, hey, we're going to build our language model off that. There's probably going to be a lot of lawsuits down the road, but for now, who cares? But I'll caveat that it's not necessarily security data. There's some security data in books, articles, right? But is it like DEF CON talks? Is it Black Hat talks? Is it private research papers? No, right? It's pretty much just all public data that these vendors could get their hands on to train the model. And I'll say something that's really important is that it's really expensive to train these models. So GPT-4, which is OpenAI's generic model, costs about $100 million to train. They trained that about last year. They recently released 4.5, and that cost about $500 million to train. And so these are very expensive, which means you can't train them that often, right? Just that'll be a reoccurring theme here as we go through these slides. In terms of thinking about different models, so there's open source and then there's proprietary. Proprietary OpenAI, Claude, Google, and then there's open source Mistral, Llama, DeepSeek, and this is like 6 of, I don't know, 20. But I think the general idea that I want to share here is that I'm not sure if that this will be like search, where Google pretty much just won that space as a monopoly. I think we're starting to see these models have specializations. So as an example, Mistral is recently specializing in Arabic, and then Claude's trying to focus on the developer space a little bit, and I think OpenAI is more like consumer. And so I think just broadly speaking about markets here, I think we'll sort of start to see some of these models sort of specialize in certain areas. So maybe a little bit different than your traditional search. Okay, so and just a few additional differences between open source and proprietary. So open source, you can run it on your laptop, so the cost is pretty much low. It's just a infrastructure cost. Performance for open source is going to be slightly behind proprietary, but you can customize a lot more. And then I'd say it's a little bit less reliable because you're probably going to be running it on your own or on your own infrastructure. But with that said, because it's there, you also have more privacy and control in terms of where your data is going. Okay, so maybe 1 or 2 more slides on foundation. So OpenAI, each vendor has a ton of different models, right? So this is a release pattern of OpenAI's models over the last year, and I'm actually missing one. There's another one that they released in September. But as you can tell, what they're doing here is they're only training models because it's so expensive. They only do it once every few months or even longer, right? And they're sort of releasing different types of models for different types of specialties, right? So they have generic, audiovisual, they have a reasoning model. And so you can imagine this quickly increases if you have each vendor releasing all these different models. And so I think from our perspective as we're building in this space, it's like, how do you know which model to use? I think it's a really important question that we'll revisit here as we move along as well. Okay. And so how folks try to decide what model to use is there's actually a lot of LLM benchmarks. These are pretty much websites that you can go to, and I won't go into how they're grading these language models, but they're essentially trying to grade these language models based on various characteristics. It could be reasoning, it could be code, and it's basically just a scoreboard. And this scoreboard changes all the time because there's this constant game of leapfrog where a vendor will release a new model and all of a sudden it's way better than the previous model. And so this is a screenshot from March 21st, and this is right after Gemini 2.5 came out. And you can see it pretty much has the best ratings across the board. And then I took one this morning, and this looks totally different because OpenAI just released 03 and 04, I think last week. So in Claude will probably release something, and then this is going to change again. And so I think it's interesting building in this space. It's like, how do you consistently try to use the right model for your use cases, especially when models are changing so fast and you don't know which one to use, right? And that's a topic that we'll talk about. Just some high-level notes. I think if you don't care about the output as much as in like you don't need it to be the best all the time, I would heavily recommend using a open source model. And if it's a simpler task. But if you really care about output, which is often cybersecurity, sadly, right? Like you want to make sure that you're using the best model because you want the best output. I'd highly recommend using proprietary. But I think the main point I'm trying to make here is at the very bottom here, which due to all these changes, even if you say that you're going to use proprietary models, it's important to build in a way that you can easily plug and play with different language models. Meaning if Gemini comes out with a better model, and for whatever reason, Claude or OpenAI starts to be terrible, like you want to be able to easily switch out pretty much your model that you're using to use whatever model that you want to be using, right? And so we'll talk about strategies to do that. Okay, so that was all foundations. Now moving to, I think, some more cybersecurity focused workflows. So CV analysis, I feel like this is a pretty standard workflow that hopefully everybody's at least somewhat familiar with. And so really when I'm looking at a CV, my first question is, what is a CV? Is there threat actor is there threat actor activity affiliated with the CV? And then is there public proof of concept exploit code? And if yes, generate it. And then more importantly, how do I fix this? That's sort of my workflow usually. And then in terms of how I would typically figure this out, I would look it up in the National Vulnerability Database, and I would read the reference links. I'd maybe Google for vendor advisories, blogs, threat intel, whatever it might be, and you're basically trying to answer these questions. And maybe if you have some vendors that you use, you probably do maybe add a few sources depending on who your vendors are for your org. Okay, so just to kind of level set, and then we're actually going to use a language model to try to automate all this. So what is the CV? Just to kind of level set again, this is what is CV 2024-4577? So this is a PHP RCE vulnerability in the CGI argument that affected the CGI component of PHP, and it allowed for remote code execution on Windows systems with specific language configurations. It's a mouthful, but and then it was used by a variety of threat actor groups, including ransomware groups, et cetera, et cetera. There is public proof of concept code, and then really the simple fix is just to upgrade it, but we'll hopefully get some more information with the language model. Okay, so I'm going to try to be a smart analyst, and I say, hey, I want to use a reasoning model because we like want to pick a right model that's going to be correct for this complex workflow, and so I'm going to use GPT-01, which came out December 2024. Just to go back really quickly, so this CV was released, it was publicly reported in NVD in June, and public exploitation started in July of 2024. And so we're going to use a model that was released by OpenAI in December 2024. And I wanted to poll everybody. So does everybody think that O1 will be able to answer these questions completely? And maybe just a raise of hands. Just kind of curious. Nobody. Okay. Partially? All right. Not at all? Oh, not at all? Anyone? Okay. So it is not at all. And it's because, as we talked about, the language model is trained basically a long time ago, and it's super expensive to train. And so even though they released this model in December, it has no knowledge of a CV that was published in June. So just to kind of give you a context of like why there's still a lot of problems with language models. But thankfully, we're not the only ones with this problem. I think most folks, regardless if you're in the cybersecurity industry, if you're in biology, like everybody has this problem where they're like, hey, we can pretty much only use or only ask it questions on, I don't want to say stale data, but older data, right? So essentially, how do we solve this problem so that the language models have current up-to-date context is sort of the big question. Okay, so there's something called retrieval augmented generation, which is called RAG. I'm going to oversimplify this again, but essentially language models have a context window. And this is in addition to the training set that it was trained on. It's essentially, you can picture it as if you pull up chat GPT and you start typing in that chat window. That is essentially you're typing in the context window. But so the context window was actually initially super small. But over time, I think proprietary vendors have realized that this is a really important feature, and so they've started to extend this context window so that you can sort of solve that problem that we just had, right? Where you can sort of shove data into the context window, and then in addition to the training set, the language model can analyze the context window for additional information. So initially, I think some of their smallest context windows initially were like 8,000 tokens, which again are pretty much just words. And I think some of the larger context windows today are close to 2 million. So I've seen a lot of growth here, and I think everybody recognizes that this is probably going to be the way of solving this problem moving forward. Okay, and just a diagram. Unfortunately, these slides are a little bit small, so sorry. But just a diagram of a architecture of a RAG application is again, you have your user query. So RAG is essentially the application recognizes that the data that it needs is not in its training set, and so it's going to go query data somewhere else. So it's going to retrieve that data, and it's going to throw it in the context window. So in addition to its training set, it's going to have this additional data that it just retrieved, and then it's going to use that in combination to generate a text response. Cool. Is this going to work? We'll see. So let's see. All right. So this is a demonstration. So we're going to use O4 here. So, or 4.0, excuse me. So OpenAI 4.0 came out a little bit afterwards. And again, they also recognize that this is a problem. So I'm going to run this a little bit. And so all we did is I know you guys can't see this because this is way too small. But it's basically we just ask the same question. So we say, hey, can you describe this CV? And what's happening on the screen here is that there's something in gray, and it says searching the web. So what OpenAI realized is like, hey, we're not going to train our models all the time. So we need a way to find relevant current data. And so this came out in the last probably 3-4 months, is they've integrated this sort of pipeline where if they recognize that their model does not have the right data, they'll query Google, they'll get the Google links, and they'll shove that data into the context window to actually generate a valid response. And so I'm just going to let this run out. So this is the exact same question, just a different model that has this RAG capability built in. And what it's showing here is that there's links on the right-hand side. And it basically uses these links on the right-hand side. It's actually doing a really cool, I don't know if you guys see this, but if you hover over a link, it actually shows like what information in the response was generated from that link. So again, it's sort of using these links to dynamically generate a accurate response. Oh, that's not good. Okay. So my argument that I'm trying to make here is that this RAG, especially for cybersecurity, where things are always changing really, really quickly, especially for threat intel, right? We want to know if a threat actor is actively exploiting something. We want to know about brand new CVEs. We don't have to wait 6 months for a language model to train on that data. This RAG pipeline, in my opinion, is the most important part for cybersecurity workloads. It pretty much doesn't matter what you're doing. In my opinion, this is the most important part. And so we're going to talk a little bit about strategies to build those as well. Okay, I'm calling this Google RAG. That is not the definition. That is a made-up thing. But Google has called this Google grounding. I've seen that. But there's this term of grounding where you're using external data sources to ensure that the language model is outputting correct data. But I just want to be clear on that that's not a real technical term. So this is hopefully a slightly bigger screenshot of some of the responses that were just in the video. So it looks pretty good compared to the first response, where it's actually giving information about the CVE. It's saying what versions are affected, and we can actually use this data as a security practitioner. Is there threat actor activity affiliated with the CVE? Looks pretty good. It notes some ransomware groups, says there's been mass exploitation campaigns. It's a little bit vague because it's using Google. Doesn't have the best threat intel, but decent. And then is there public proof of concept code? It says yes, but it doesn't generate it for us. We'll actually talk about generating code here in a little bit, but that's generally a pretty good response with this RAG workflow. And then how do I fix this? It sort of gives us some versions to upgrade to. So pretty good using Google, right? So drawbacks of this is that I don't want to have to manually go into OpenAI and type a question every time. That sounds terrible. I'd rather somehow automate this. So essentially what we just showed is sort of like a point-in-time analysis using Google. We also don't get to control what sources the language model is using, right? It's using Google. It's just looking at search engine optimization articles, really. And so we don't have control, right? If you're an organization and you probably have your own threat intel, or maybe you want to use whatever sources you want to use, you don't really have a choice in terms of what the language model is using. And then, again, this is more for your enterprise or organizational perspective, but the answer also isn't customized to your network. This is pretty much just a generic answer. It doesn't have any context about your network. If you're looking up a CV, it's probably because you're affected by it, maybe, or you're trying to figure that out. And a generic answer is just okay. Okay, so how do we improve this? Automate all the things. So we're going to try to automate this. And then also, as I mentioned, in terms of, we also want to integrate with internal data. So that's relevant to our network. So not necessarily just public Google data, but maybe if we have like a CMDB, right? We want to pull in that information into the context window so that the LLM has that. Custom threat intel, if you guys are Mandiant, CrowdStrike, Palo Alto Networks, pick your vendor. Their threat intel is usually a lot better than what's on Google. And then last thing, maybe if you had like a SIM or an EDR, Splunk, whatever it might be, kind of pulling in that relevant data into the context window as well. So we'll walk through some strategies here. Okay, so to do that, to automate this, we're going to build agentic systems. So it's sort of just automating exactly what we just did. You're just going to write some code to do it. So I understand this is small again, but essentially each proprietary vendor has their own API, right? So you can write a Python library and you can integrate and pull a API call and automate sort of that question and response answer, right? So this is feasible, but going back to the topic that we talked about before, because how quickly language models are changing, if all of a sudden OpenAI starts to be terrible, right? We want to be able to quickly switch to Gemini or to a different model. And so I don't want to have to write this 6 times for each model vendor that I want to use, right? And so how can we basically make this a little bit easier so that we can easily change language model vendors? And so I'm going to propose that we're going to use agentic frameworks. So this is a relatively still newer space. It's probably like 2 years old, which I guess is about how old most of since language models have blown up. But essentially, they're abstractions on top of the language models that allow you to easily be LLM agnostic, right? So that you can plug and play, and I'll show an example of this. And they also come pre-built with a lot of popular agentic patterns. We'll walk through a few of those. And then you can also provide the language model some tools. We'll walk through that. The one downside is that because this space is so new, even these libraries can be a little bit unstable. As an example, so there's LangChain. LangChain and LangGraph are actually the same company. They just released different tools. CrewAI is a separate startup, and then AutoGen on the right is Microsoft's framework. But because of how new this space is, like if you were to use LangChain.1, and then you would try to upgrade to LangChain.2, most of your code would break. So thankfully, it's getting a little bit better and more stable, where that's not really a problem anymore. But I still highly recommend using these frameworks. And so we'll walk through some examples. So just one example here. So in pretty much you just need to change one line of code to change your model, and everything else stays the same, right? So this is sort of the benefit here. Is again, if you wanted to use Gemini, Claude, OpenAI, you just have 3 lines and you can comment one out, and everything else stays the same. So it really allows you to kind of plug and play and figure out what works for you, or for your use case, which model works for you. Okay, to go into a bit of depth in terms of some terminology here. So Anthropic came out with a blog in December where they're trying to sort of define some nomenclature for agents, and I'm going to try to use their blog. So there's workflows, which are agentic patterns that have predefined code paths. You can think about this is actually LangChain. That's what the name is suggesting. You're sort of chaining together things, and you can't go backwards. You're just going from one place to the other. And then there's agents, which give the language model a little bit more flexibility in terms of how it wants to accomplish tasks. And so this is more a traditional, what's called a DAG, which is a directly acyclic graph, or directed acyclic graph, where essentially the language model can sort of decide how it solves the problem. And we'll kind of walk through both of these as well. Okay, so building workflows. So we're going to try to automate this. Just starting with the top question. So in terms of if we wanted to describe what the CVE is, really what we're doing as humans is we're reading through all of those national vulnerability links in terms of like the references that are included in the national vulnerability database, and we're trying to summarize that text, right? That's pretty much what we're doing. And then same thing for threat actor activity is essentially we're going to read a variety of blogs, and we're going to try to summarize that text as well. And so really it's a text summarization workflow. And so I pretty much just describe this, but essentially again, this is the NBD table, and all you're going to do is read through all those links and try to answer these questions. Okay, so I'm not going to go over this, but this is just a good example of, I think, the power of LangChain. So cybersecurity isn't the only vertical that's trying to summarize text, right? And so what LangChain has done is they've basically built these pre-built workflows that try to automate common patterns. And one is a text summarization pattern. They do a bunch of fancy MapReduce stuff. I haven't looked at MapReduce since college. I don't want to look at it. And so I just use their basic function to summarize all this data, right, that we're going to throw at the model. And so again, it's just an example of sort of one use case where LangChain sort of has this complex text summarization workflow that is pre-built into that framework. There's also different types of workflows. Just to kind of show one more example, there's also a refine. So instead of using MapReduce, essentially for each article in that NVD table, if you go back, essentially they also have a pre-built workflow which is called a refine. So basically it's going to ask a question, it's going to read the article, and it's going to generate an answer. And then there's this workflow where it's going to iterate through every single article. And if the answer changes, or if there's information in the article that contradicts its first answer, it will update its answer, right? So that's called a refine workflow. And so there's different use cases for all these different workflows. I think y'all would have to figure out what works for you or for your specific use case. As an example, I think for the refine workflow, which is a little bit different from the summarize, is that maybe if you wanted to say aggregate evidence of threat actor activity, right, it would read through each article and it would update its answer based on activity in each article, right? Versus if it was a summarize, maybe it'd miss some of that, right? So it's sort of like you have to figure out which workflows work best for your questions that you're using the language models to analyze. Okay, so agents. So there's LangChain and there's LangGraph. And if we were to go back to a few slides, there's CrewAI and then there's AutoGen. I'll say that I mostly use LangChain and LangGraph here because I like their marketing, just in terms of like, I think it's easier to understand. If you're doing a LangChain, it's a predefined code path. You're just going one way. LangGraph is more of you're providing an agent the ability to go back or to choose how it wants to do something. So this is a basic example that I pulled from their documentation, but basically is that at certain points there will be a option for the language model to basically say, hey, something's wrong, like I want to go back to a previous state, right? Or it could also be like, maybe I want to choose which data source I want to query for a certain data set. So you're sort of giving the language model the ability to, again, kind of choose how it solves a problem. Okay, so these more the agentic component of this is usually more used for more complex workflows. So generating code, if you guys have ever used Cursor, Copilot, these are all more agentic, just because of how complex a lot of these tasks are. And then also, I would argue for like how do I fix this? I think that should also be agentic, especially if you're trying to customize it with whatever internal applications you guys use. And so we'll walk through this example. So just to give an example, again, a security example of a agentic framework. So let's say that we want to remediate CV 2024-4577. We can sort of have an orchestrator agent in your network, and the orchestrator agent gets to make a decision about the data that it queries for. Right. So in one instance, maybe we want it to understand additional information about the affected asset, meaning like which web application or host has this PHP installed, and so it would know to query the CMDB. Right. If you guys are ServiceNow shop, Freshworks, sort of picking various CMDBs, or maybe this isn't a good example for PHP, but maybe the vulnerability we're analyzing is Cisco. Cisco does not have public documentation, I'm pretty sure. And so basically we would need to build a different way for the language model to query Cisco's documentation. And so we can do that through a vector store, but that's a different topic. But the idea I'm trying to make here is that we're giving the language model the ability to query for things that it thinks it needs to solve a problem. Right? So it has a little bit more flexibility. We're not doing a predefined, hey, you need to query this thing to get this answer. We're actually letting the language model figure it out. And probably what you can even have here as well is that once you get that data, there's a synthesizer agent which sort of takes that data and combines it. And I think what is very common in more agentic patterns is maybe you would have an arrow from the synthesize back to the front, where the synthesizer can also make a decision like, hey, do I even have the right data? Like, do I need to go back and query for more data? Okay, so I'll say that RAG, in terms of retrieval augmented generation, was initially designed actually for vector DBs there at the bottom. So basically searching through a huge amount of text and getting contextual information relevant to the question. In terms of integrating with CMDBs at the top or integrating with any application, right? It could be Splunk, it could be pick any security product. It's really hard to do that today. So building language model integrations is generally pretty tough. It's like, can you have the language model query a API to get the data that it needs? It's not a clear answer. There is something on the horizon that I want to briefly touch on, which is the model context protocol. That's something that the Anthropic team released, I think, also in December, and it's starting to gather adoption. There we go. But really, it's trying to assist developers in writing these more complex agentic workflows, where the LLM all of a sudden is able to easily query different APIs. And sort of, it's almost like a browser. How a browser is allowing you to interact with Gmail. It's sort of like allowing the language model to interact with different products. And so there's also there's a pre-built list of integrations that are being built. So Anthropic has a GitHub repository where there's, I think, probably a few hundred model context protocol servers, and essentially, again, these are pre-built integrations with your favorite apps. So maybe you want the language model to be able to query Google Calendar, your Gmail, Splunk, ServiceNow, and it's sort of allowing that interaction to be a lot easier. And again, I'm oversimplifying this a little bit, but hopefully that makes sense. Just in terms of a graphic, it's almost like you can picture as if you're plugging in a USB, and all of a sudden your computer now can do, for those of you that like hacking, like maybe you want to put in like a Wi-Fi adapter, or whatever it might be. Essentially, you're just plugging in a USB to your language model, and all of a sudden it can query Slack, it can query Gmail, it can query Calendar, and sort of build those integrations a little bit more seamlessly. Okay, and just a quick slide on the differences between MCP and API calls. Again, I think to use the browser metaphor, I think it's sort of an easy way to think of it is in terms of like, you're not doing a single call. It's more of like a state and a session that the MCP is allowing the language model to have with that application. So it manages context and memory, and I think this is kind of going down the weeds a little bit, but it definitely allows for more complex implementations with different data sources. Okay. Let's get this. Okay, so out of the technical weeds for a second, I think as we talked about at the very beginning, even if we have all these fantastic integrations, language models, and especially with cybersecurity, our risk threshold is very low. We don't want a language model to do certain things that might take down our network. How do we build this trust with language models to augment our work, right? So there's this idea of trust but verify, where essentially we're going to try to have humans in the loop for a lot of these interactions, and a human gets to say, hey, this looks good or this does not look good. But I'll say one of the core problems here is preventing against hallucinations. I think, especially folks that have been using language models for a while, hallucinations used to be really bad. I remember when I was initially looking at this, and I would do the same question, just describe the CVE. Instead of saying, hey, I don't know anything about the CVE, the language model would just reply with complete nonsense. Like, it would talk about a different CVE from, that was not related at all. Some of the newer models have these sort of built-in protections where I think actually a lot of this is just going to naturally go away. But it is still a problem for the foreseeable future. I think if you're going to use open source models, it'll be for a while. Whereas I think if you use a proprietary vendor, they're going to have a lot of built-in protections that sort of prevent these pretty bad problems. Regardless, though, we want to manually verify the language model's response. And so there's a few options to do that. One is chain of thought, which we'll talk about briefly. And then the other one is to include or have the LLM cite its sources. It's also another interesting avenue to go as well. Okay, so to talk about chain of thought really quickly, it's actually pretty simple. You're just going to prompt the model to provide or generate a step-by-step explanation of how it got to its answer. And it's actually interesting. There's been studies that show that the language model's output actually just improves on its own if you ask it to do chain of thought. So it's sort of you're almost like forcing like a third grader to like show their like math process or something, and then all of a sudden it improves. So it's sort of interesting. But in addition to that, right, you can go through and look at the steps that it used and manually verify if all of a sudden it makes a logical jump that doesn't make sense to you. You can sort of flag that and say, hey, something's wrong here. I probably shouldn't trust this response. I'll say, so one other option is, this is more getting back to the agentic frameworks. So there's evaluators. When I think I briefly talked about this, this is a very common pattern where you'll have a LLM call, the LLM will generate something, and you'll have a separate language model that assesses the output of the first one, right? So it's almost like you're doing paired coding, or you can think about you're working in a team with somebody, and this second language model is an independent assessor and can say, hey, this doesn't look right, regenerate your response. So a very simple example of this is we build a lot of workflows that have the language model generate JSON or Markdown. For whatever reason, the language model will just generate garbage sometimes. Garbage is in like the Markdown format will be wrong or the JSON format will be wrong. And so if you have a secondary language model that says, hey, this is incorrect JSON, like the syntax isn't right, like redo it, it actually works pretty well, right? You gotta be a little careful that you don't get into some infinite recursion and rack up your AI bill, but generally it's a pretty good strategy that most companies building this space use today. So this is a bit of a more complex example of the same thing. This is an example of generating code in terms of what that actually looks like. There's a lot of back and forth where you have multiple agents that are sort of looking at the code like, hey, is the syntax right? Is this part of the problem correct? And if at certain points of the problem, it'll pretty much just go back and regenerate a response. So again, if you use Cursor, if you write code, if you use pretty much any modern LM application, there's a lot of this type of workflow where each step in this workflow is pretty much an AI agent that is doing tests. You can automate QA, you can pretty much do whatever you want. Right. So again, I think more towards security, you can have it validate threat detection syntax if you're generating rules in Splunk, et cetera, et cetera. So you guys can be creative. Okay, where are we going? I think just to kind of talk about some newer things in this space, I think folks are starting to realize that RAG is really important and that there's a big problem, especially in cybersecurity, again, with getting up-to-date information. And so just a new thing in the space is Google released what's called SecGemini, which is a specialized model. They released it earlier this month on April 4th, and they claim, I'm taking this from their blog, so combines Gemini with near real-time cybersecurity knowledge and tooling. They're purposely a little bit vague on how they're doing that, and they also say they have an integration with Google Threat Intelligence, which is Mandiant, because they acquired Mandiant, OSV, and then other key data sources. Unclear if it's fine-tuning, which we didn't really talk about today, or if it's RAG. I hope it's RAG, because otherwise it's not going to be great. But again, I think there's these sort of specialized language models that have these pre-built-in integrations with different data sources is going to be the future. And more on like what I think we're building here is really trying to build these integrations with different data sources. So again, if you're looking at a CVE, right, and you want a language model to augment a lot of what a vulnerability analyst is doing, you're going to want the language model to be able to query, if you guys are using Tenable, Qualys, Rapid7, SemGrep, whatever the vulnerability source is, and then combine that data with your CMDB, again, ServiceNow, Freshworks, SolarWinds, doesn't really matter, and then firewall, right? So you want to know maybe, hey, does this host have an internet-facing connection, right? And you're sort of integrating all these data sources and so that the language model can make the right decision. And so again, that's probably going to be mostly with MCP. But this is also new that we'll find out. Okay, in summary. So I'll say that this space is still changing incredibly fast. I started writing this talk, I don't know, months ago, and I've had to update a ton of slides. A portion of this talk will probably be out of date in 3 months. That's just sort of the nature of where we're at in terms of language models. This space is evolving really, really quickly. I think that for folks that are looking to integrate this into their internal workflows, I really think they're an improvement on traditional scripts. Right? If you're using Bash, if you're using Python, if you're using PowerShell, AI agents just give you more flexibility and more capability in terms of augmenting a lot of what you'd like to do, right? And it's, I think we've all written scripts before, and if you can build on top of a language model, I think you'll be able to automate a lot more faster and I think more accurately as well. And so I hope I encourage folks to start building. And that's it. Appreciate everybody's time.